This our Earth, a traumatized planet. Global temperatures have risen by 1.2 degrees C compared to the time of the Industrial Revolution. This has led to serious consequences such as extreme weather, rising sea levels, and declining biodiversity. The main cause of global warming is the emission of large quantities of greenhouse gases, such as carbon dioxide, methane, and nitrous oxide from human activities. According to the journal Nature, every 1 degree C rise in global temperature leads to a 2m rise in sea level, 13% loss of ice caps, 30% extinction of species, and 70% coral bleaching. There is no time left. What should I do as an architecture student? Designer alarm, a constant reminder. There is our idea of a building that is capable of monitoring the dynamic SSD in global temperature resembling a thermometer. To mitigate the environmental impact associated with building construction, an eco-friendly material shellcrete. After establishing a building that serves as a functional equivalent to a thermometer for presenting the temperature, a range of complementary complexes are incorporated on the top of the cliff. Many years later, a building constructed with seashell cement could serve a dual purpose. Measure tomorrow. Because of its special shape, I simulated it with Karamba to get the optimal solution for the structure. Controlling the variables, only the structural form of the truss diagonal brace was changed. The graphs and deformation results show that the V-shaped internal diagonal brace structure achieves the best utilization and the best structural strength while ensuring the minimization of axial stress and max displacement. In order to investigate the length of the building's cantilever distance, a comparison was made between the absolute values of the 5 different cantilever distances, max length displacements, and the set displacement thresholds, in order to obtain the optimum cantilever distance of 30 meters, which not only results in a larger cantilever distance, but also ensures the stability of the structure and the utilization of materials. The building projections is to ensure that they are structurally fixed by slings. Therefore, it is necessary to study the optimum angle between the slings, while keeping one section of the slings fixed through another fixing point by axial stress displacement and utilization, but also ensures the stability of the structure and the utilization of materials to find the optimum fixing point between 3/7 and 4/7 of the building length. By means of the Karamba algorithm, the entire building design is structurally optimized to obtain the most reasonable and suitable building structure. This process ensures that the building design achieves the optimal balance between aesthetics and functionality. After forming the building structure, the temperature data is projected on top of the thermometer building. Global warming began 180 years ago, and the warming of the planet has been linked from the beginning to the rising concentrations of greenhouse gases caused by the Industrial Revolution. With global temperatures having risen by 1.2 degrees Celsius, all regions of the world are facing unprecedented changes in the climate system and adverse climate impacts. The Paris Agreement, reached in 2015, sets out to strengthen the global response to the threat of climate change by limiting the increase in global average temperature to 1.5 degrees Celsius. A 2 degrees Celsius rise in temperature is a major tipping point for the planet, because if it does happen, it will mean that the global warming trend will be completely out of control. Under this temperature, with 95% of organisms extinct, the planet will face total catastrophe and ecological disaster in full swing. By visually displaying thermometer data, we hope to raise awareness and encourage individuals to take more responsibility for their impact on the environment, helping to drive positive change towards a more sustainable future.